Hello, everyone. Good evening, good night, good morning, afternoon, whatever. How are you all?
Good evening, ma'am.
Yeah, hi ma'am.
Good evening, ma'am. Fine.
Hello, ma'am. Good evening. How are you?
Oh, wow,
Hello,
wow.
ma'am.
What up, audience? Praveen, Deepak, Pankaj, Sumit. Good, good. How are you all?
All good, ma'am.
All good, ma'am. All good. What about
All
you,
good,
ma'am?
ma'am.
All good, all good. Thank you very much. And
Means that the people are waiting for this session from long time.
yes,
Yeah,
yes,
we are doing
they were asking me,
exactly,
but
sir. Exactly.
yeah, too much occupied actually. Sorry for being a bit delayed. So, okay, finally, so what I'm going to do now in this session, we will be covering some sort of, going to set you some sort of motivations, because this Wireshark training, it will be not too much, maybe just a 5-hour course, or sometime we can divide it into days, also 5 days course only. So here the agenda of this course will be number one, to address your practical troubleshooting points. Okay, let me just share my screen. Wait a minute. Okay, so I hope this is visible to all, right?
Yes, ma'am.
Yes,
Okay.
Yes, ma'am.
Okay, fine. So after this, I'll take you to walk you through the Wireshark also, what it is. And people who are new, I'm sorry, I was very comfortable with my own people here. And my name is Shagun. I've been the trainer for networking since last couple of years. So I'm basically representing Palo Alto firewalls here. So I train people on Palo Alto. And this session was mostly requested from my engineers, from my trainees who've been getting trained from me. And this course, the agenda that I have designed in such a way, because why we have this Palo Alto courses, after that people will be joining their positions as TAC engineers or maybe the senior engineers. Their position will be based upon your troubleshooting skills. So this troubleshooting skill will be, when it comes to Wireshark, this is the main aspect. This is your, we can say the building block for any troubleshooting stuff. So when we say troubleshooting, what you will be, for example, let's say we can have some demonstration of your firewalls. Let's say here we will be having your firewall, let's say this side LAN side, that side WAN side. Okay, this is your internet stuff is going on. So if you will be receiving, let's say you are the TAC engineer. TAC engineer means people who will be working on those live cases. So they will be having some sort of tickets, people who will be using as their clients. Now the client, let's say if I'm TAC engineer and let's say some ABC person is my client and they are generating the one ticket, they are having some issues with their firewall. That client is also, it's not a normal client. They are also the admin of the firewall. Maybe they are the admin of any hospital firewall, any medical other organization, banking firewall, any educational firewall. So it depends upon the organization, but they are also representing the admin. So sometime you are working as a tech engineer after maybe 6 months as an engineer, working experience, 1 year experience, but you are maybe solving the case who is already on the other side, 20 years experienced person than you. Okay. So it is mandatory to understand the problem first, break down the problem into small parts, and then you have to come up with, most of the time when we are on the troubleshooting time. So we are going for your log analysis. Second one is your packet captures. Okay, so this packet captures, we are having the facility on our firewall also under monitor tab. If you will be going, there is a very wonderful option. It is called packet capture. So you can have that packet capture also. Whatever the packet captures you will be having, these files you can open in any format. Wireshark format is one of them. These packet captures are this traffic that firewall is handling. Okay, Wireshark. Now, when we say this Wireshark comes very handy when it is not just your firewall. Maybe you want to check what kind of routing traffic is going on, what if anyone is hitting you with, let's say, TCP SYN scan, any ping scan, Christmas scan. So this comes under where kind of malware detections. So you have to know about what is Wireshark. Wireshark, it is a kind of tool that is called, we normally say this is your network sniffing tool, right? You can just capture. Till date in the world, nobody can stop you. Nobody can stop, in fact, anyone to capture what is traveling through your wires. So whatever is traveling through here to here, anyone can capture it. So that is the main tool people use it, Wireshark. So now what is traveling through the wire? We know it very well. It is just as per the standards of our OSI. Okay, so this is number one point to be noted here. You should be very, very clear what is OSI doing in your packet capture. Okay, so here you will be, whatever the Wireshark coverage is, captures are, it will be starting from layer 1, then layer 2 will come into picture, layer 3 will come into picture, then your layer 4 will be here, and after that, whatever the captures are. For example, if you are pinging somebody, okay, so I'm just pinging from here. Let's say I'm on the LAN side. I'm pinging from my LAN to 8.8.8. That is Google server is somewhere over the internet only. So my ping request is flowing from here to here. So this ping request, it works on which layer of OSI? This is working on the layer 3. So whenever you will be capturing these captures, so you will be having layer 1 captures, because how the data will be flowing, we know very well. So whenever the client side captures are going on, it is always from all these 7 layer will come into picture, and it will be from top to bottom approach. So now if your data itself is being generated from layer 3, that is your ICMP request. If you are generating the data from layer 3 onwards only, so there is no way it will be having any layer 4, layer 5, layer 6, layer 7 header, right? So every data, whatever we are generating, they are having some sort of headers. Headers normally I explain in my trainings. I give one example in my trainings. So headers are like when you go to, most of us, we believe in astrology a lot, right? So we go to some sort of these astrologers. They will give you a very nice drawing after asking who you are, what is your name, and this kind of drawing. I can't draw it properly, but some sort of drawing will be there. Okay, I don't know. So that is called your kundali or whatever. So this is also a kind of animation. So it is like, it is depicting whatever is going on in your life. It is a format. It is basically a header. Similarly, in our computer networks, whatever is traveling through layer to layer, every layer is just to keep on adding such kind of formats into the data, so that when the data will be received on the other hand, they will also be meaningful, just like the way they got sent from the client side, they will be equally meaningful to the receiver end also. So every layer, they will be having very, very close communication to each other. So now over here, I was giving you some idea. Wireshark captures, if you are able to see the captures, any capture that you are able to see, layer 1, layer 2, layer 3. So the highest layer is layer 3. That means that data was generated from layer 3 only. That means it was a ping or any other layer 3 traffic. IGMP could be there, multicasting could be there, anything could be there. So if it is, let's say you just want to check, you are generating, so now I can ask just a random question. Let's say I'm generating this traffic, HTTPS : then // let's say google.com. So what we will be having in the Wireshark captures, layer 1, because now your data itself is getting started from layer 7. So it will be traveling from all the way from layer 7 to layer 1. So it will be layer 1, layer 2, layer 3, layer 4, layer 5, layer 7, and layer 6. But in Wireshark, you will have layer 1, layer 2, layer 3, layer 4, and directly your layer 7 services. So this is what we will be having right now. I will be giving you some example of the various Wireshark captures. So before I start, I'm going to share one website with all of you. This is one of the very handy website if you want to learn about all those captures. It is called packetlife.net. This is a wonderful website. Here you will be having so many packet captures. They have already generated for you. You can just go ahead. Now, let me just walk you through the Wireshark now, how Wireshark will be coming and playing some sort of roles here. So basically what I will be doing, I will be, I have designed a very small course for this one. And in this one, I will be covering, let's say your, what do I say, various kind of layer 7 protocols. All those services will cover, and I will cover your, what do I say, those all headers. Okay. So now again, I'm going to share my screen. This is the Wireshark capture. So this Wireshark capture, so if you will be, this is SMTP. SMTP, it is your layer 7 service. We know this. So now this SMTP, this is the face of your Wireshark, by the way. When it is open source, it is freely available to anyone and everyone. You can have it. So you will be having, for example, file, edit, view, go, capture, analyze, stats, then your wireless, other tools will be there. Main tool will be here only, and your most of the time you will be use your stat. Okay, under file, you will be having some sort of main actions here only. If you want to open any Wireshark captures, you want to make a capture also, and then you want to merge them. It's not like always already ready-made files you can capture. You can start capturing your own traffic also. So whenever the Wireshark actually gets started, it is a direct capture I started. Normally, whenever you will be doing the installation of Wireshark, first page itself, it will be showcasing you, it will be asking you, Wireshark, you want me to link with which network? So if I'm using multiple networks, my Bluetooth network, it can capture your Bluetooth network also. It can capture your LAN also, your WAN also, anything. So it will give you these kind of details. Timestamps will be there, source IP will be there, destination IP will be there, protocol will be there. Here you do not get confused with your protocol and your service. Protocol means whatever the protocol is doing that stuff now. And next, it will be telling you whatever your bytes, how many bytes are being covered. Then information will be some sort of human readable format. Normal thing, if I will be now just analyzing this SMTP traffic for you. So for example, this is what I have. Okay. So this is my domain name system. So this is your DNS query. So most of the time when this is one more plus point over here, 90% people, they don't know which layer 7 service is actually supported by which layer 4 protocol. If you will be doing some practice on your Wireshark, now see, this is layer 1. If I open layer 1 on the top, it will always give you some sort of your physical interface related data. Everything will be, for example, whatever your previous capture timing was, how many packets it is being covered, and then whatever your timings are there, whatever the duplex settings are there. This is not something that we have to check. Okay, so this is all about your layer 1. Here comes your layer 2. Layer 2 will always check. First thing will be your source. Okay, so this is your source. This is your MAC address is coming into picture. This guy is your destination. So this was your destination's MAC address. On the top layer, everything will be giving as the conclusion. Layer 3, it is source IP, destination IP. Layer 4, it is your source port and your destination port. Okay, so now let's see here. This is your layer 2. So layer 2, we know very well there will be all information available for your MAC addressing. So they are saying a destination was this one, and this is what it was happening to them. So for example, it was a globally unique address. So we will understand what type of MAC addresses we also have. So what are the categories of MAC addressing? So that is what they are giving. So everything, whatever you are able to see, this is based upon, if anyone knows whatever the format of a MAC address, how MAC address format would look like. These are called layer 2 headers. We have to understand first headers. So this course is totally getting deep dive into your headers only. Let it be your layer 1. Layer 1, we do not have any header at all. Layer 2 header will be discussed. Layer 3, layer 4, and layer 7, all the protocol services will be discussed in this small course. It's not a very big course, maybe 5 hours, 6 hours, we'll see. And then this is your all about the second stuff, that is your source MAC address. So these are again, some values are 0, some values are 1. This is again as per the definition of the MAC, whatever the computer networks they are understanding in the way. Now this is why whatever I'm talking, you guys all are understanding. Why? Because I'm using a language that is following certain kind of standards that is globally understood. So this language is understood to all of you. So same thing, these computer networks, they are also kind of communication is going on between various devices. They have to use a certain kind of standards that every device, even let it be your source, let it be your destination, or maybe intermediate devices who are coming in between them. So they are processing this traffic. So they should be on certain kind of standards. So that is the reason why we do have the headers. So you might have heard there are two major headers. One is called your IP header, then your TCP headers. We have TCP headers flags, we have IP headers flags. Then we have DNS header also. Then we have DHCP header, ARP header. Every single thing is nothing but a header only. So all these headers, layer 7 headers, we will cover in this one. So this guy is now your IP header. They are talking about your IP header. People who were maybe into my class, they might recall. So first few bits, that will be your 4 bits will be out of 32 I'm talking about now. So this is your IP header. Okay. So we will be talking about how the IP header will be working. I'll be giving you one header example now. This session will not be too much long. So this is IP header. So this is how header will be talking about 32 bits. It is IPv4, right? All those 32 bits, how they are being utilized, right? So this is all about header. Everything is happening in the form of 32 in IPv4. All those 32 bits, how we are organizing in multiple layers, not only just one. So for example, this out first, there are multiple, it could be like not just one single row of, if you are thinking about like, okay, she's saying 32. So I have a stream of 32 bits and this is my header. No, nothing like this. So your header, maybe it could be like, whenever, remember when we send any data, not data, to courier or to letter to somebody. If I'm in city 1, let's say I have to send a letter to city 2. So from city 1 to city 2, there will be actual letter that I will be writing down, hello, how are you, and all. That is called data, right? So but now that guy will be saying me, enter your control information, enter your header means enter your details as per the header, as per the format. Then they are asking me, enter your name, your address and your phone number, and then whatever any extra information if they can have about me. So why this is needed? So because in case of a failure, any delivery cannot happen, they can come back to me, they can contact me anytime. Same logic is applied on computer networks. So basically computer network, I would say, if you want to understand computer networks, understand the way how transportation in real life is working, understand how the courier service in real life is working. It will be making your life much more easier. Okay, you don't need to worry about these things. So this is your data, whatever you are saying, hello, hi, how are you? So, and this is your control information. In computer networks, we say this is a header. Who is sending? Who is the receiver? So source, destination, these are the part of your header. Every single type of traffic, it is your nothing, but they have their own way of representing the data, how they will be processed. So for example, if you will be going to any, let's say, bank, so one queue is there where you have to get your bank account open. There is another queue is going on where maybe you are waiting for some sort of deposits. You are there just to deposit money into it. So everything has different way of getting it done. Similarly, any kind of traffic that we are generating, we are pinging sometime, we are playing video games, we are listening music, we are on Zoom, we are on live stream. These all are nothing but different kind of traffic that we are generating. And these all little are protocols, they are helping together itself. So they are like working in a team. So that this data can be processed. How they are processing, they are doing their own duty, and then they are handing over the data to data means all together, this whole thing, whole information, they are handing over the whole information to next layer protocol so that they can also perform their own duty. So they are not mixing with, so for example, layer 2 stuff, they will never ever mix, they will never put question on layer 3, whatever is happening. So they are just to stick with their own responsibilities. And this is one of the most, I would say, wonderful example in the world. If you are following certain kind of a hierarchy in any organization also, in your real life also, whatever is assigned to you, you just dedicate to that. Whatever is assigned to others, try to do not mingle with them, so that you can perform your own duties very well. So every protocol has its own dedicated duties, and these duties are mentioned in every header. We have headers. Every layer 3 header, layer 4 header, layer 7 headers are too many headers that we have to understand. So these all will be the part of this just few hours course. We will be designing in the way. And then this is what your IP header. These all are informations available for your IP header only, how the IP header is looking like and all. Then comes your last thing will be, for example, let's say now I have UDP. SMTP, now if you will see, SMTP is based upon which layer 4 protocol? UDP. Why? Because it is already UDP is the base protocol here, right? Sorry, not SMTP. This is the DNS protocol I'm opening. So DNS is actually on UDP, and DNS is only service in the world that uses both layer 4 protocol, UDP also, TCP also. UDP means whenever one DNS cannot resolve your question, cannot resolve, not question, sorry, it is query, and it has to transfer it from your side, from your behalf, it has to transfer to some other server, DNS server that is next to him, and that is much more having entries as compared to this DNS. So from one DNS to another DNS, queries will be based upon your UDP. And in case the last server is now giving you the reply, now that reply will be coming back on the basis of TCP, because it has to go back to directly to the source who generated the query, not going backtrack like this. So this DNS, this packet is your DNS. And this is how under the DNS now, what is this transaction ID? What are the various flags? So we do have the DNS flags also here, truncated, for example, reserved, recursion required or not. This is what I'm saying, recursion required. So I can give you just a random idea over here. Let's say I do have, I have this is my, I'm working at home now, and I am connecting with I want to go to some sort of website, and these are little DNS servers coming in between, and here is the actual server that I want to talk. Okay, so now let's say I generated first of all, DNS is not something that you will explicit generate the traffic. It is automatically being generated whenever you are opening any web page that so far you haven't opened yet. It will automatically generate. The first step will always be your DNS lookup only. So let's say I'm trying to open very first time www.google.com. So first thing, now your PC, it is a computational device. It understands the language of computations. Computations on what? Computation on binary numbers. And binary number, how they are getting done? First of all, they are calculating everything into decimal. Then decimal is being converted into binaries. So when I'm saying try to open HTTPS www.google.com, HTTPS again will turn into a number. Everything will be turning into number only. HTTPS, then your whatever your URL is. Okay, so they will be turning out into number. So let's say HTTP is 443, and your URL, let's say it is 8.8.8.8. That might be the traffic. I'm not saying it now like Google server is having, this is Google's DNS server. But I'm trying to just give you an example. Any URL could be cisco.com also, but at one point, at end of the day, they are not URL, they are just a number for your computer. So before they are getting traveled through wires, they are getting converted into numbers. So 4438888, and now you, until and unless this entry will not be completed, you cannot start establishment of any connection at all. So first step is complete this whole thing. This is called a socket. So this socket has to be created within your system. So we call this is the client side socket. Similarly, once everything will be processed and you will be going through all those 7 layers from here, once the receiver will be receiving, it will create a server side socket also. So now let's say this is your IP, but now how I received this IP? I was typing www, that website's URL. First, my local DNS came into picture. My DNS said, I do not know where exactly this is, but I have two options now. One is called iterative results. Another one is called recursion based response. Now your DNS saying, I am supporting recursion also, and client can also request. Sometimes there are client side settings that you can say, I just want recursive only. Now, what is the difference between recursive and iterative things are? Iterative means every time your DNS is receiving the request, it is giving you idea. Say it is saying, sorry, mate, I don't know whatever your URL is, but here is the IP of this DNS. You please go and contact him. Now you are going to contact him. Same thing this guy is saying. This is saying, sorry, even I don't know. I can give you the IP of other guy. You please go and contact him. Now you are going him. And same thing, this guy is having the IP. Now it is going back to you, give you the direct IP with. So now here you're breaking your head over multiple times. This is called iterative process. So every DNS server is keep on giving you those IPs and you are generating the traffic on your own behalf. So this is iterative. Now, what is recursive? Recursive means you have generated the traffic and you said, this is not my headache. If you don't know, then you have to find out at any cost. I don't know. So now this guy will be saying, okay, I do not have, but wait for a minute. I'll be getting some details for you. Now it is contacting next one. This is contacting next one. So they are contacting each other like this, but this guy will be coming back to you. So here comes the real application of TCP and UDP. This process will be carried out with UDP stuff, everything UDP, and this is TCP. This is because now you are coming back directly to the server, source. So this is going to be handed over to the TCP stuff. So this is how the difference between various services and how the underlying protocols will be coming into picture. That is based upon understanding the header of individual protocol, DNS, TCP, UDP, IP, then ICMP, ARP, DHCP, SMTP, telnet means whatever your remote access is there, then SSH we do have, NTP protocol is there, network time protocol. These all protocols are very, very important when it comes to your troubleshooting. Otherwise, it will not be very easy. You know, in telnet, you never try to take telnet from your, let's say, organization, or never even allow somebody to take the telnet. The reason is, I show you in a bit, if I can find that header over here. So this is what the flags will be. Again, everything is a format. Now I'll give you some ideas on what a format would look like. This is the DNS format. It is saying recursion is desired. So it is client side saying recursion is desired. So client is not ready to have iterative results and all. So these are different values. I'll explain you whenever it is a great discussion. But see, DNS, this is a query. So in the bracket, because we are being human, it should be a bit more understandable for us. So we do have two type of DNS format. One is called a DNS query, and next one will be your DNS response. This is your response. So this is what server will have sent to you. So this is all about your DNS stuff is going on. Next one is, if you want to check which service is using which protocol as layer 4, you can just check from the this Wireshark tool also. It's very easy. Next one is, you might have heard about SYN, SYNAC, ACK. So this is after DNS, what is going on? This is your TCP three-way handshake is going on. So now if you will be checking now, this is the way. Now you understand we do have DNS lookup. Under the DNS lookup, let it be your query, let it be your response, but we are having how many entries? 1, 2, 3, 4, and 5. Why? Because DNS, it is a layer 7 stuff. It is a service of layer 7. So that is the reason layer 7, layer 4, layer 3, layer 2, layer 1 will come into picture. Layer 5, layer 6 won't come here, right? So now let's say TCP. How many layers we have? Layer 4, 3, 2, and 1. Why? Because the TCP got started itself from transport layer. Transport layer did not touch on the up layers. So now transport layer is going to start your, after DNS lookup, TCP handshake would occur. This is the clear text, communication is going on. So this is the header of your TCP. Source port, destination port, then your sequence number, then you do have some sort of relative sequence number, raw sequence number. What is the difference between relative and raw? So raw means your actual sequence number. Now, what do we mean by sequence number? Sequence number means now, okay, let me just share my another screen, but let me just go walk you through. I'm just going to explain you the TCP header only so that you can understand. Just note down these things. Sequence number, right? Acknowledgement number. Then you do have header length also. It is saying 28 bytes. Then you do have flags. So we do have 9 flags total. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these flags are not top 3 flags are not the part of your TCP header, because they are already moved to the layer 3 devices, routers and other firewalls, or any other appliances that are dedicated to routing. Because this ECN and your accurate ECN and CWR, so these all are dedicated to the routing stuff. When 2 routers are fighting for the bandwidth to send and receive the data, so these flags will come into picture. Otherwise, your TCP is genuinely having 6 flags, that is called SYN, FIN, reset, push, acknowledgement, and urgent. FIN means finish, SYN means synchronization, push means pushing the data, first time data is coming on the track. Acknowledgement means every data, whatever is being delivered on the other side. So you are getting an acknowledgement, and then you are having one urgent. So these are the 6 flags. Most of the time, whenever we appear for any kind of interview, their pet question will be specifically for Palo Alto people, I'm saying. So Palo Alto interviews, they will be pet question. How many flags are there in TCP? So you have to say, I have total 9 entries in the header when we capture those onto the Wireshark. But generally, we do have 6 flags in the TCP header. So we have SYN, FIN, and all these things. So their next question will be, what is the difference between urgent flag and push flag? So these are the values that we, now I'm just talking about these flags only in the next bit. So these are your flags. Now they are saying flag is set is a SYN right now, SYN, because this is a SYN segment. Okay, so this is a TCP handshake's first segment. So client is sharing the SYN segment with the server so that they can check with each other whether server is not allowed, is interested to serve the client or not. So this is called SYN segment. Here we do not say SYN packet. No, not at all. It is called SYN segment. Okay. If the next packet is SYN plus ACK, you can already imagine here acknowledgement will be 1, SYN will be 1, and here you will see 2 flags. Let's just imagine here. If I open this one, so here acknowledgement is 1, your SYN is 1, and A and S are here. Same thing. So another one is called your window side, checksum is there, and then options. Now let me unshare my screen, and now I have to explain you the TCP proper, what do I say? Header, okay? And now we have multiple headers. Out of them, TCP plays very, very important role. So let's say I have a TCP header. This TCP header, why we have, number 1, whenever the client, let's say I'm trying to open www.google.com, I'm the client and server is Google's server that is already in US right now. So when that I will be having the home page of google.com after hitting the enter, once I'm done with www.google.com, typing in the address bar of Google Chrome. So these all things will be happening behind the scenes for you at the back end. For example, DNS lookup will be done, and then since an ACK will be done, because now you are at the port number 443 also, SSL handshake will also be done. So in this case, we will read about SSL a lot. Now, let's say in our TCP, there will be some sort of entries. So we do have TCP. This is a TCP header, not data, just a header control information we are talking about now. So first information, we have a total, how many bits? Total length is 32 bits. So from here to here, that is total 32 bits. In TCP header, first thing is, it will be talking about your, yes, anyone has idea from my classes? Anyone wants to participate? What is the TCP header would look like? No one?
Version.
Yes, version. Okay, so total we do have 1, 2, 3, 4, 5, and from 6 to 15 onwards, all these lines will be here. So total you have 15 lines, but normally we use 5 out of them, right? Now I have every line, this segment, not segment, I would say this small portion of this TCP header, they are having 4 bytes. Okay, here 4 bytes. Why? Because 32 bits, right? Everyone is 32 bits long. 4 bytes, 4 bytes, 4 bytes here, 4 bytes here, 4 bytes here, and 4 bytes here also. So minimum length that we normally use in TCP, that is until and unless it is not required. So that is only first 4 lines. So that is the reason your TCP header size I'm saying now. So your header size is how many bytes? 5 into 4 means, or 4 into 5, whatever. It is equal to 20 bytes. Okay, so this is minimum size, and maximum, how many rows are here? You have 15 rows. So each row is 4 bytes. So how many bytes will be total? 60 bytes. So this is how, first of all, you have to understand whatever the size meaning. Size means this altogether, length into breadth. So how much will be the total bytes that we will be consuming? So this is only header. So first one will be your version. Okay, there will be some number of bits will be allocated to here, and then no, here we are discussing TCP, right? There is no version. Sorry.
Port and district.
Yeah, this is no version. This is not version. So first 16 bits are reserved for your source port. Another one is called your destination port. So these are the 16 bits that are reserved. So here 16, here 16. Next one is 32-bit long number. So this is called your sequence number. Next, again, 32-bit representation of your acknowledgement number. So next one will be your first 4 bits are reserved for how many lines are using you, right? Because now normally we start with everything from 0 to how many? Whatever, 15, right? So how many numbers, how many bits we need to represent anything that is coming between 0 to 15? That means 4 bits you need. So here normally you have 4 bits to represent. And usually we have value as 0, 1, 0, 1. Reason is because we are using first 5. So that is the 5 length. This is length, this is size. So do not get confused with 2 things. So next 6 bits are reserved. So these are reserved bits, just R for reserved. Next 6 bits are for your flags. These are your 6 flags: SYN, FIN, urgent, push, and acknowledgement, and reset. So these all are your flags here. And these remaining 16 bits are reserved for your something called windowing. So this is called your window size. Okay. Next one is called your, here comes your last part. So it will be 16 bits will be reserved for your
Checksum.
Checksum and urgent.
Yes. It will be checksum, and the last 16 bits will be for your
Urgent point.
urgent pointer. So there is a very great connection between your urgent pointer, and you do have something called urgent flag also. So this is what your main format of TCP, you have to understand it in this way. So over here, normally we say these are optional field. You do have some sort of other options. Other options means recorded routing can be done here. You can have so many other options that that may be needed in the satellite communication or somehow. So NTP protocol, whenever to specifically in controller systems, there are some machines they have to control, they have to sync those all machines with each other. So NTP protocol will be working on the behind. So those kind of synchronizations can come into picture. So but in normal computer networks routing, these are the normal things that we will be having. So these are extra things, padding can come here. Okay, so now we know, you know, these are the port numbers. We have some theory behind your port numbers. We have total 65,536 port numbers available in any machine. Machine means wherever you have internet. Let it be your laptop, let it be your PC, let it be your mobile, tablet, anything, your smartwatch, anything. Everywhere, wherever you do have internet, there we do have total 65,536 total port numbers. These port numbers are ranged between 0 to 65535. Okay, so now how these things are, these further things are also very, very systematically arranged. So out of these, we do have 3 categories. Number 1, number 2, number 3. First category, it is called your well-defined port number. So well-defined port number, we do have a range for them. That is from Zero, in fact, zero we also already consider for your well-defined port numbers only. It is dedicated to the dropped traffic. When we come to the firewalls and all, it is dedicated to the dropped traffic that is keep on getting dropped by your firewall. So from 10 to 1023, these are the port numbers that we will reserve in the sense they are fixed. So for example, let's say port number 23. Port number 23 is for your telnet, right? 25 is your SMTP. 67, it is your DHCP. 68 again is DHCP server. So maybe 53 DNS. And then you do have 443, that is for your HTTPS. 80 is your HTTP. So these all will be falling in the category of this only, because they are well-defined port numbers. Well-defined port number means these are the port numbers that will always resemble to normal traffic when you will be generating any traffic. So it can be, it will be your destination port. You will never see your destination port like, okay, 65,000, something like this. No, because it is not recommended. There is no service that we have in the layer 7 where we have that 65,000 as a port number. Next category, it is called your reserved port numbers. So reserved port number, we do have number from 10242 all the way up to 49,151. So this is your reserved port number. Then last one is called your random port numbers. So these random port numbers are 49,152 onwards to all the way up to 65,535. So now what is the difference between random and reserved port numbers? The reserved port numbers are reserved, as their name is suggesting. They are owned by, sometimes they are paid also. So they are owned by certain companies for their internal VPN connections. For example, in Palo Alto, we have GP, that is your remote VPN that we normally use. So for GP, we use 4501. And also we do have 21,000 port number. For troubleshooting purpose, when it comes very dense kind of troubleshooting, we go for 21,000 also. So these both port numbers are belonging here only. So these are the port numbers that we will be assuming, like, yes, there will be a traffic, but once you will be connecting to their internal connections or VPNs. So that is reserved. That is the reason it is reserved. Now, random port number. Random port number is the category where whenever you will generate some traffic, your source port will be picking as a random number. So it will be 16-bit number, like just like this. And it will be any number between 49,152 to 65,535. So it will always be from this number and series only. It will never cross anything. So your source port will be random port numbers. Your destination port will be always well-defined port numbers. If you are working on any kind of VPN or remote site VPN, then you can see any idea from here also. So this is the theory behind your port numbers. So now that is the reason you have 16 bits, right? If you will calculate 2 exponent 16, 2 raised to power 16. So total, it will give you, what is the total? 65,536 as the count. That is the reason we do have total these many ports. So this is the main reason behind our port numbers. So now source port, destination port. Now sequence number will be a very big number because it's already 32-bit number. So you can imagine it will be a very big number. Acknowledgement number, so as just like your sequence number. So now here will be a difference. Sequence number, for example, let's say I have, let's say I have a viral fever. Now I'm contacting my doctor. I'm just having, first of all, I cannot explain everything on phone. Randomly, I'm calling, I'm saying, okay, fine, I'm having this issue. They won't be treating me like this, right? They are already busy. So now you have to imagine, doctor, it is kind of a server to me. I'm a client. He's a server. Why it is called a doctor? Because he is worldwide recognized. He is following certain kind of standards. Everyone knows when we are falling sick, we have to contact a doctor only. We are not going to grocery shop to enjoy anything, right? So, same thing. Why do we have these headers? Why do we have these computer network RFCs rules? Because just like you are not feeling well, you have to contact doctor. Same thing. You should be having some sort of common sense in your computer networks also. That is the reason we have headers. So these headers will be telling you, okay, how to process every information. Now, in my case, let's say I am having some fever now and I have to call to doctor. So I'm calling doctor, and doctor is not all the time free. They will be having some sort of receptionist also. So she will be asking me, okay, what time you want to visit? So they will be giving me a time. At that time, then I'll go and ask to visit the doctor, final appointment. Same thing. If you are seeking some sort of a service could be, so that is the reason we have to understand what do we mean by service in OSI model. Service could be your DNS, service could be DHCP, service could be your SSL, service could be your any SMTP also. Telnet is also a service, FTP is also a service. All these things are service. So similarly, doctor is a server to me. Why? Because they are providing the medical services. Now, if I have some problem with my debit or credit card, definitely I have to go to the bank only, concerned bank. In this case, I don't want to call to doctor, right? My bank debit card is not working. So common sense, we are establishing some sort of common sense in computer networks through these headers, how the process will be done. So now this first time when the client will be contacting your server, because the first time we are generating some sort of random number. Okay, because every communication will be getting recorded. They will be having some sort of numbers associated with it. So you will be sending one control information to your server, but you are just picking any random number in this one. Now you are saying, I am looking forward for port number 443 services. Are you available or not? It is kind of fixing one appointment before you actually ask what you are looking at 443, right? 443 means you are not looking right now. You are not saying, give me the home page. Right now, you did not even mention whatever the requirement is. You are first fixing one sort of appointment. So that is just asking on the SYN segment. So under SYN segment, you do have source port, you do have destination port, you do have one random sequence number, and you do not have any acknowledgement here. So if I have to prepare one SYN segment, so this information will be there, this information will be there, sequence number will be there, but no acknowledgement. Acknowledgement will be, for example, if this is client, this is server, this is the first packet that is segment is going to be on the server side. It is a SYN segment. Now, how can I acknowledge something? Okay, fine. Previously, I have received this one. Nothing, right? Nothing. This is the first packet, first segment. Now, there will be no acknowledgement number. It is not applicable here in SYN segment. So similarly, this information will be filled and this is reserved with. Now under the flags, your SYNs, just like the way you have already seen on the Wireshark. So SYN segment, SYN flag will be set to 1. This is the only flag that right now will be set to 1. Window size, yes, it will be introducing its window sizing also. Checksum will be the value that will be a calculative hashing code of your source port and sequence number in such a way that when this segment will be received by your server will also calculate whatever they have received, and if the checksum, whatever they have received and whatever the server has calculated, if they both are not matching again the same, so they will be just simple dropping the traffic. So this is just for the kind of your authenticity checking, integrity checking. So now it will be for that purpose, whether the data has got compromised during the transit or not. So the checksum will be there. Then your this urgent pointer. Now, urgent pointer and flags, I have, this is my next discussion now. And after this, your options will be there. Anything extra that is coming into picture, so that will be coming here. So that is all about. Now I have to talk about these two important things. One is called 6 flags of TCP. Another one is called your urgent pointer. So now let's say 6 flags are, one is called SYN, then I have FIN, then I have acknowledgement, and then I have urgent, then I have push, and I have reset flag. Okay, so I have total 6 flags here. SYN flag will be whenever I will be sending first packet or first segment, or maybe once the connection will be established, server will be sending me SYN plus ACK, and then I will be generating those ACK. Acknowledgement number will always be there. Whenever you have previously received something from the other party and you are saying, yes, I have received your previous message, you just want to acknowledge whatever, just like in official email, we received a kind of email and we are acknowledging, yes, I acknowledge it. Same thing, acknowledge flag will be whenever you have received something, you just want to acknowledge. Now, finish flag will be whenever you want to just finish the connection. It's not we as a users, we will never ever come to know what are the flags are working behind the backend. So it is like automatically your socket programming is working. So fin flag will be generated by automatically from your network operating system through socket programming whenever there will be no data transmission going on between these two, client and server. Because now let's say you can take one more example, same example we can continue. I went to the doctor after the appointment. Now, whole day I cannot just sitting idle and just keep on watching the face of doctor, right? They will be just kicking me out of the clinic after this. So the same thing, once there is no data transmission is being sensed on the wire, automatically these socket will be generating the fin flag from the client or server. Either side they can generate, there's no problem. So they will be saying, okay, there is no data being now on the wire. So let's finish the connection so that the same connection ID, whatever the connection I have established with there are other users. So same server is being, in contact with the many other users also. So let's free this connection ID so that any other required user can talk to me on the same ID. So this is what the fundamental behind your finish flag also. Acknowledgement, now you know. Okay, so now reset flag, first of all, let's say. Reset flag means, let's say I have a server. This server, this is my IP, here is my LAN cable, whatever it is connecting, and this is the IP that people know me by. Let's say this is Google server. This is the IP on cable that is configured, and this is how public know me. And now this server only supports port number 80 traffic. This TCP SYN came here as on port number 443. But this server do not have any certificate services. So it is just a clear text server. It has no port number 443. So once I will be receiving TCP SYN, rather than saying SYN plus ACK, now I will be sending the reset flag. So reset flag could be if your desired port number, it is not being supported by your server, or maybe server is too busy, you cannot reach to the server. So that is the reason reset flag is coming. That means reset flag coming from the server side. That means server is not interested to have any connection with you right now. That is the problem. So this is a function of your reset flag. Okay, so now I hope we are clear about these at least things. Urgent and push flag now. So the difference between urgent and push flag is, so whenever we will be sending data, let's say there are 2-3 terminologies now we have to understand. First of all, TCP three-way handshake will occur. SYN, SYNAC, ACK. This is done. And after that, now the connection is established. Now, once the connection is established, every data will be going through with the sequence number and acknowledgement number between client and server. So these will be depending upon every chunk of bytes that we are sending from client to server side. Every, let's say 1400 bytes, they have fixed out this as the window size. So every 1400 bytes, there will be a new morph packet that we have to send to them. Every packet, new packet will be having its own sequence number. Let's say this is my 0th packet, this is first packet, third, and so on. Now, there is a way how they will be sending on the wire. First of all these sequence number will be generated and they will be somehow going into a kind of buffer. And from the buffer, it will be going to the window so that they can send to the wire. Now, this is buffer, this is your window. You can imagine sometime we go to any mall, right? So there you go for payment. So same queue, okay? And after that payment, you can take the example, very good example of airport check-in. There will be a line, then there will be different cashiers, and you will be just, they will be going and serving your boarding pass and all. Same thing. So this is my computer. This computer is generating some sort of traffic. This traffic is hitting first buffer and then window. So now what will happen if if there will be any segment or data where I'm saying urgent flag is set to be 1. So normally, what was the fashion? Since ACK is done, now the actual data, not just your handshake signal, now the actual data is traveling. Your google.com's data is traveling. So that will be push flag will be 1 and the actual Google's traffic will be coming. So this is your Google's traffic. This is now telling this is a real traffic. Push flag means real data, whatever they want. Urgent flag, if it is 1, now normally every data will be keep into pushing into the buffer and then going out of the wire. Now, if any, let's say if there is any, you can take the example from airport only. So there is, let's say I'm standing here, people are standing here, I'm standing here somewhere. And there is one politician comes. Now what will occur? Politician is obviously it is on the priority. So will he wait here in the buffer? What do you think? Will he wait here in the buffer? Will there be any waiting for the politician or not? Any leader? No, right? Why they have to wait? Because they are the on priority. Same thing. Any data with whatever is having urgent flag is set to be 1, they will go directly from to the first person next to be sent. That's it. That is a difference between push and urgent flag. Push flag means just normally following the fashion. Urgent flag means do not wait, just go directly next as the next person to be sent. So this is how your TCP would work. This is just, I think, 60% the discussion on TCP. There will be a lot more things that we have to understand. And in this course, what I have designed, we will be discussing every aspect of your all the headers. This is what my main discussion is. And we will be doing so many captures, so many reading of all those headers, how the packets are going on. So this is what we have designed so far. Any questions for me now? No?
Hello, ma'am.
Yes, yes.
Ma'am, is the session you will put on the same portal so that we can?
This session, I think it is on YouTube. It will be remained on YouTube. Maybe I'm not too sure, but let's check. It's not on portal anyway, so there will be, I think, on the YouTube only.
Okay. So, ma'am, you will take the classes for this Wireshark at the same time?
Yeah, it's just a
next
5-hour course, maybe 5 to 6 hour course will be here. You can split it into 5 days or maybe just a 5 hours course.
Okay, so you will inform us in advance when you will take the class, right?
Once the registrations, I'll ask Gaurav sir whenever they will be opening the registration for this one. So we will be taking. So it's not
Sure.
because I believe once you are already having some sort of basic fundamentals clear, you can jump directly to such kind of courses because within 5 hours you should learn. So you have to be a bit quick rather than for going long-term courses.
Okay, I'm sure. Thank you.
Yeah. Okay. So any other question for me?
Yeah, actually, ma'am, how to capture data from Wireshark?
Okay, Wireshark, let me just open, wait a minute. Try. Okay. Sorry, I am not sharing my screen. I'm just directly going. Okay, so here, let's say I'm typing here Wireshark. Okay, so I have already installed. You need to install this application. Whenever this Wireshark will be getting open, it will ask you, like, this is the very first phase when you will be opening the Wireshark. So it will ask you what exactly you want to capture. So if you have any VM installed, like I have VMware 17 Pro also. So it is asking me, do you want to capture any VM data or whatever? So there will be some other connections. For example, this is my Wi-Fi. If they want, they can go for any other traffic also. If I'm saying Wi-Fi data, so I just want to select it. Automatically, it is now being captured, whatever I'm sending, because right now we are on Zoom. So it is a quick protocol that is going on. That is a UDP based transmission is going on. So this is what continuous packets are traveling. So you will say, so everything is traveling from my side towards you. Okay, so that is the data. If you want to stop it, you have to just click on this red button. Blue means capturing, stop means this red. Got it?
Thank you.
Yeah. Okay.
How do we save the capturing packet?
Okay. Whatever you have already captured. So let's say again, I have to share this one. So you have already captured, right? And now you just want to somewhere save this one. So maybe this somewhere you will save this packet file. And let's say I want to see my PCAP. And now this is already, now let's say I have saved somewhere in the, let's say desktop. Okay. So I'm just saving it here. Now it's saved. Now again, I have to open it. Let me just again go back to my desktop. So many windows I'm opening. Okay. Oh, I'm not sharing my screen. Okay, fine.
Yeah, correct.
Actually, it got automatically unshared. So this is the file. Okay, this is what the file I have. Wherever the file. Let me just. This is file. Can you see my PCAP, the one that I captured? This one.
Yeah,
Now,
correct.
let's say I have to open this file, and now it will be opening like this, whatever I have captured. Okay, so this is what I have captured.
Okay.
Yeah. So you just need to capture and save it whenever you want. So there will be a lot of traffic that you will be requiring to capture and all. See here, can you see this is source port C 57,000 something. Okay, that is belonging to the actual one. Now destination port is 8801. So again, this is something from your reserved port numbers. This is what we have to know. Similarly, there will be your, these are called your hex codes, all. So whatever I have, there are so many beautiful things about packet capture and your Wireshark. So if you go to these tools, can you see this credentials? Okay. And can you see these firewall these things, ACL rules? So Wireshark can be very aggressive that it can capture certain kind of your, very next rules that you have to have. So we will be understanding how these things are working, how to make sense out of your TCP and how to make sense out of your UDP. You can have so many graphs also. If you will, today time was limited, otherwise I could have. So this is your follow. Whenever you have some sort of any meaningful data you want to understand, that is create text, you can follow this one. Okay, I want to showcase you one example. Wait a minute. That will be giving you eye-opening experience. Wait a minute. Okay, let me share the screen again. Okay, this is the telnet capture. Okay, so I hope it is visible to all of you. This is okay. Now, if you will see, normally you won't understand what is it is written, like so many entries are here. It is like telnet header. It's a very big one, but I want to understand what has happened in telnet. Normally, what I have to do, right click over here, then you have to go to follow, and then you have to follow the TCP stream. So it will tell you very meaningful data. Like somebody tried to log in with the T test, and then password was this, and username was this one. So this is what was happening. So this can be very, very dangerous. That was the reason why I was saying never allow anyone to go for telnet. Always, if you want to take the remote access, always go for SSH. Not just go for telnet. It is very, very dangerous. Anything can be available as it is. That was the reason actually why port number 80 is now no more in the market now, because port number 80 was also showcasing you the same stuff. Whatever you are doing shopping on your Amazon, and then you are entering your credit card details, it was freely available like this. Anyone can use them, whatever you are entering.
Madam, sorry to interrupt you, but how we can able to know which type, in the sense of which packet we need to click on it, and we are able to see other information, like you are saying all the things.
Yeah, that will be with practice. For example, whenever you will be every TCP stream, just like the meaningful data I have shown you, such kind of a flow will be there on certain kind of layer 7 services. In telnet will be there, SMTP will be there. There are few examples where we
While
can
making
have.
the connection, continuously the data and the packet is flowing, na? So it is also Wireshark also that capturing that all the packets and all the things. So how we know very well that this is the particular packet we need to read, and we
No,
need
it
to
is
capture.
like at a time on my PC also, let's say there are multiple traffic is going on. I have opened more than 150 tabs in one Google Chrome. So every single thing is generating the traffic. Whatever we are capturing whatever is traveling through my Wi-Fi. So it is capturing every single thing. So whenever you will say that telnet as a layer 7 protocol, so you have to click over there, not everything like this.
Single thing also, we if we are able to connect to the internet and we are just started our Wireshark over the Wi-Fi or anywhere else. So
Yes, we have to
it's
filter
also,
those.
yeah.
There will be filters, Wireshark filters. That's what I'm saying. Today, time was not very effective because I was also very tired. But I requested the team like this. Everyone was keep on asking me when this session will be there. So there will be filters. How you filter the traffic, because you are having millions of data. So we will be using certain kind of Wireshark filters. So for example, you just want to see anything related to telnet only. So you will be typing the filter as telnet on the address. Just there are filter
Also
bars.
possible, is it also possible to capture the data if while we are using only web browsers or any particular web services like that?
Yes. You can. You cannot just capture the particular data, but you can capture everything. Then you can just do one thing, apply one filter, extract that data, save to another file. This is what we can do.
Okay, and if any another software or any application is using the internet, then it is also possible to capture those data as well?
Yes, Nmap also. Anything, Nmap, Zenmap, everything can be captured.
Okay.
Yeah.
So
Okay.
it will, is it possible in the sense in the next lecture, if we possible to see this all things?
Yes, I will be trying. And now what I will be doing, I will discuss with all these things. Maybe there are other people also. So I'll put like a timetable when we can do. Actually, I was too much occupied, very occupied, continuous on traveling. So that was the reason I couldn't just come back. But I knew it. I remembered like you asked me for the Wireshark analysis. Yeah.
Thanks for that.
Okay, no problem.
Just a last question, that the recording session will be available na after completing the class Wireshark?
Yes, I guess maybe it is on the YouTube right now going on, so it will be there on YouTube.
Not this one, but the course which we will register for the Wireshark, and those courses, the few hours you are saying. That's it.
Yes, it will be. Everything will be recorded.
Okay, so we will get that
Yes.
recording things. Okay.
Yes.
Okay.
Why
Thank
not?
you.
Yeah.
Hello.
Yes. Please tell me.
Ma'am, would you help us to learn about network mapping and network testing as well? Like there is several tools that are available. Like as you said that Nmap is there and SQL is also there.
Yeah, look at what we can do. I have included so far, honestly, I have included Nmap, like various kind of attacks I have included into the curriculum. But if you have any special packet captures with you that you want to analyze, I would say more than welcome. No problem. We can analyze those also.
Okay.
Yeah.
Thank you.
Okay then. Okay. Oh my God, so many. I didn't realize how many people are here. Okay. Anyway, so any other question for me? Okay, you do one thing, you all maybe just get in touch with the team. So they will be announcing when the course will be started. I'm not going to put too many hours into it, maximum 8 hours, but I'm planning already. I have designed up to 5. I can extend maximum up to 8 hours, but let's finish it in within 10 hours only. No need to stretch more than that. So 8-9 hours are more than enough. And this course is specifically for people who are on the troubleshooting side. And this is a crucial part. Every networking engineer, every networking person, they have to have this knowledge. Without understanding those headers, seriously, it is meaningless whenever we are thinking about the troubleshooting part, or specifically for your various kind of interviews. After reading those and having some idea about these headers, you will have a very good idea how the packet flow is working in every device. Let it be your router, your firewall, any vendor firewall. You don't need to worry at all. This is a very, very plus point in understanding those headers. Okay, so maybe Gaurav sir, we can wrap up for the day if there are no further queries.
Yeah, I think fine.
Yeah,
And
thank
thanks, Raghu.
you.
Thanks for that.
Yeah, thank you everyone.
Thank you, ma'am.
It's a
Thank you.
wonderful,
Yeah, thank
wonderful
you so much.
response.
Yeah,
Yeah,
good night, ma'am.
yeah,
Good
Deepak, Sumit,
Thank
Praveen,
you so
everyone.
much.
Yeah,
Thank
thank
you.
you very much. It was a wonderful
you.
response to all of you. Thank you
Yeah,
very much, everyone. Thanks. Bye.
Good